Okay, it's you guys' turn to do this little example right up here. So pause, try to work it on your own, and then come back to this video and I'll zoom through the author's solution to this problem. Okay, here we go. Author solution. We see that the admittance of this guy, a half, admittance of this guy, minus a half J. Siemens, that is, reciprocal ohms. Admittance of this guy, negative G, when you take the reciprocal of J, you get a negative J. And that can be found if you just multiply J by top and bottom. J times J, here I'll just do it right now. J times J is -1, J times 1 is J. So the reciprocal of the imaginary constant is the negative imaginary constant. Okay, so reciprocal of this would be positive 1J. Reciprocal of this is 1/4. Simple. And then you convert, you just collect terms now. And convert that. You can use the absolute value function and the arg function in MATLAB or New Octave to find the angle. In the case of the arg function, you're finding the angle. In the case of the absolute value function, you're finding the magnitude. And then we can get the current equals the admittance times the voltage. So there's the admittance times the voltage. 10 times 9.0 or 0.9014 is 9.014. And then add these two together. 20 plus 33.69, 53.69. Did you get this answer? I hope you did. Okay, moving on. I'm going to do the next example here. This one's complicated. You're not using anything you don't already know. You know how to do this. It's just big. That's the only difference. That's the only real difference. Break the problems down into smaller pieces. So I want to know the equivalent resistance of this one. Well, they're in parallel, so I need to take the reciprocal. And that's going to be 1. 1 over 1 is 1, and the units are inverse ohms or Siemens. 1 over negative 2J. 1 over negative 2J gives you half a J, positive half a J. Okay? Now, comma, ZE1 equals I hate the way my little eraser, I hate the way my little input device works. It sometimes makes the 4 into a 9. Okay, and the equal into something weird. Okay, Z1 equals 1 over 1 plus a half J equals 1 minus. You multiply top and bottom by the complex conjugate. Oops, not G, J. The complex conjugate times
the number and its, excuse me, a number times its complex conjugate is just the real part squared plus the imaginary part squared, which is 1.25 equals 0.8 ohms minus, well, 1/2, well, yeah, this is half, this is 4/10 of 0.4 J. So that's the impedance of this. This is the admittance here and the impedance of that little part. Okay, let's consider this part next. Do a similar procedure. I'm going to go quicker. ZE2 equals negative 1/4 J plus 1/2 J equals 0. I'm going to do some erasing. 25 J. The admittance here equals that, not the impedance. So get this erased. Reciprocal impedance. This is 2, ZE2. Okay. Reciprocal impedance is reciprocal of this plus the reciprocal of this. Okay, and then the reciprocal of the admittance is dominated by the capacitor. The capacitor has lower impedance. More current flows through there. So you expect the answer to look like a capacitor, which it does. Okay, so we got that part. Let's add it. Let's get the impedance of this, all this stuff, which is just taking this and adding it to these two impedances. So Z equivalent 3, and that's not ZE1, that's ZE2 right there. ZE3 is 4 ohms plus 2J ohms. That's this guy here, plus finally this guy here, minus 4J ohms, equals 4 minus 2J in ohms. There, quit making my 4s look like 9s. Stupid machine. There, 4 minus 2J. Okay, now we've got that one done. Let's get this one. This is in series also. So we have ZE4, Z equivalent 4. Oh, boy. One of these days I'll learn how to make a 4 without it messing up on me. Okay. ZE4 equals, supposed to be an equal sign, equals ZE4 equals 2 plus 6J minus 2J. sum these three together. 2 plus 4j. Okay. And that's a plus sign again. Make it big and obvious. Now, we got to take these in parallel. This one here and this one here. Put those in parallel. So 1 over z5 equals 1 over z3 plus 1 over z4. Multiply top and bottom by its complex conjugate. 4 plus 2j over 4 squared plus 2 squared is 20, plus 2 minus 4j over 2 squared plus 4 squared is 20. Okay. Equals, this would be 6 over 20, which would be 3/10 for the real part, the 4 and the 2. This 4 and this 2, that's negative 2 over 20, or 1/10. Okay. I'm going to pick this problem up. I'm going to resume this problem on the next video.